A nucleophilic substitution reaction is a reaction where a nucleophile substitutes another nucleophile. So, what are the nucleophiles? A nucleophile is a species that has a lone pair that it can donate to a positive carbon. For example, hydroxide ion, chloride ion, bromide ion, water, ammonia, all of them has a lone pair that they can donate to the positive carbon. So that brings us to the concept of carbocation. There are two types, actually three types, but we're going to learn only two: tertiary carbocation and primary carbocation. In the picture, you can see a tertiary carbocation. Here, this carbon, you can see that one carbon is positive, and this carbon is not attached to any hydrogen. Rather, there are three alkyl groups attached to it. This particular type of carbocation is very stable. Why? It's because the three alkyl groups, they are electron donating. So what they do is they push electron towards the carbocation, positive carbon, making the positive charge spread around, which makes the whole carbocation very stable. And in another example, we have primary carbocation. A primary carbocation have two hydrogen attached to it and an alkyl group attached to it. It's not stable because only one alkyl group can donate electron to spread the charge. So a primary carbocation is not stable. So that's it. That's all you have to learn to know further about nucleophilic substitution. A nucleophilic substitution reaction can be two types. One is SN1 and SN2. We are going to discuss SN1 at first. Here in SN1, it happens between a tertiary alkyl halide and an aqueous potassium hydroxide or sodium hydroxide. The tertiary alkyl halide is tertiary because the chlorine atom that is attached with the carbon atom, you can see, the carbon that is attached to the chlorine atom does not have any hydrogen attached to it, only three alkyl groups, and it's very important. Now the chlorine atom has a higher electronegativity than the carbon atom. So what happens? The chlorine atom tries to get all the electrons in the shared electrons from carbon, and chlorine becomes slightly negative and carbon becomes slightly positive. Eventually, the chlorine atom can break away from the carbon and become a chloride ion. And the carbon, by losing electron, the carbon becomes a positive ion, which we can say a carbocation. So let's see in the animation. You can see that negative ion forms, slightly negative. Chlorine ion breaks apart, carbon becomes positive. And I told you earlier that this is very stable. This carbocation is very stable because it's tertiary alkyl halide. And the hydroxyl ion then attach with that, forming a tertiary alcohol. And that's it.